Okay, so in this video, I'm going to take a look at some of the differences between traditional econometrics and machine learning. The paper that I'm referencing here is from Daniel Hoang and Kevin Wiegratz, and this is a piece of academic work published in 2023. I think they both hail from Karlsruhe Institute of Technology in Germany, and they go through quite a bit of detail. And also, if you're writing a dissertation or an academic paper on machine learning with financial applications or applications to economics, I think this probably could be used as quite a useful um, primer on what's the key literature. Um, the table one that I'm going to just discuss very briefly here is taken from here, and I've set it up in a spreadsheet. And I found it instructive, especially when we're trying to understand a little bit the dynamic between traditional econometrics and machine learning. What these two have developed is this idea that if you're working with traditional economics, normally you're identifying independent variables that cause a dependent variable. And an important model, but not an exclusive model, is linear regression. So most econometricians, their first port of call is linear regression, and it's a kind of it's an explanatory model, and sort of um, assumes that you have some kind of priors or some kind of understanding of how the economy works, and the model that you develop is based on maybe a very strong economic grasp or an economic intuition. The application or usage is on causal relationships, but a lot of the time you're trying to use p-values and r-squares and looking at the very precise your hypothesis testing on each of the individual variables in the regression. What you're trying to estimate very often is the coefficient in the regression output. And you're trying to look at the strength, so of the beta coefficient and the overall fit of the coefficients in the regression. Supervised machine learning is a bit different. Again, you're definitely trying to predict Y, so you're trying to figure out what leads to Y, and we have causal variables or independent variables. And in the supervised machine learning method, you could be using OLS, but also the whole suite of other machine learning tools like random forest or support vector machines. In that instance, you're very often trying to look at how good the model predicts Y. You may not have a strong set of priors. So an economist might approach a particular problem and have some kind of theory that underpins the model that they develop for their econometric analysis. And it's born out of a strong kind of intuitive economic intuition, where somebody coming more from the machine learning end is coming from more an empirical and perhaps less theoretical. So less theoretical priors, more driven by empirical outputs. A lot of the time, you're a little bit agnostic about precisely which model you're applying, but very focused on the level of prediction or the accuracy of your model. And then for robustness, you're using out of sample prediction. So very often you set up a scheme where you train your data, then have a holdback or holdout data set or a test data set where you take the model and you apply the model with the out of sample data. And then you check for the robustness of the accuracy measures. So in some respects, you may approach the problem totally agnostic in a sense, devoid of economic thinking. You might just be trying to predict house prices. An economist might have strong sense of what are the factors that contribute to the microeconomic understanding of what's going on in a market, and that conditions or influences a lot the way they develop the model. The difference with people coming with a stronger leaning towards machine learning and applying machine learning techniques, a lot of the time the model is a sort of a black box, and so we don't really understand what's happening in the model, but we do look at how the model predicts, and then we look at out of sample data or holdback data, and we try to see, does the R square, is it robust for the out of sample data? And then for the unsupervised learning, we may not even have a particular why. We just try to let the data tell its own story. So in that sense, we don't understand completely what's happening. We're not sure what the chain of causation is. So in a sense, we have unsupervised, and the data structure and the structure model and data characteristics and structural information from data structure inference. So in a sense, we don't know where we're going to. We don't know what exactly we're trying to predict, but we're sort of approaching the problem as if we'll let the data reveal everything. And it's even more strongly agnostic in terms of even understanding what's likely to cause the target variable, because we don't identify a target variable. Traditional econometrics utilizes labeled data to apply linear regression for OLS. And we were very often interested in the statistical significance, and the goal is to explain causal relationships represented by B hat, beta hat. Supervised learning also uses labeled data, but employs supervised machine learning methods, and it focuses on predicting models and evaluating performance, aiming for out of sample, denoted by Y hat. And unsupervised learning deals with unlabeled data to discover the data structure using unsupervised machine learning methods, and it aims to infer structure by revealing structural information from the data. A good source for setting up some of these problems with data that's explained simply is a source here from John C. Hull. I'll just give the web page. It's John C. Hull and his web page, right? So if we go to John C. Hull website. And if you look under, he has 4 textbooks currently out, and this one, Machine Learning in Business, I think it's really machine learning in finance, because a lot of the examples are very much in the domain of finance, and it's a beautiful textbook that takes you through many of those areas. So if you're coming from a finance or economics background and you're looking for applications of machine learning in finance, John goes through unsupervised learning, supervised learning decision trees, support vector machines, supervised learning neural networks, further applications, reinforcement learning, natural language processing, model interpretability, and issues for society. Every chapter in the textbook here is supported by data, and both Excel and Python typically, and extremely useful, intuitive explanations provided. And also you have the PowerPoint slides as well. Okay.